In this example, data from a sample of 50 students were used to build a regression model using quiz averages to predict final exam scores. We're asked to construct a 95% confidence interval for the slope. This example uses the Exam.MTW dataset. The regression model has already been run, and we have our coefficients table here. This is the general form of a confidence interval: sample statistic plus and minus the multiplier times the standard error. We're constructing a confidence interval for the slope, so our sample statistic will be the sample slope. The multiplier will be a t-multiplier with degrees of freedom equal to n minus 2. The standard error will be the standard error for the slope. In this particular scenario, we can find the sample slope and the standard error for the slope in our coefficients table. These will be in the row that's labeled as the x variable quiz average. The sample slope here is 0.7513. Next, we need the t-multiplier. We're told that n equals 50, so our degrees of freedom will be equal to 50 minus 2, which is 48. I'll take you over to Minitab Express to construct a t-distribution with 48 degrees of freedom. We're constructing a 95% interval, so we'll be looking for the t-values that separate the middle 95% from the outer 5% of that distribution. I'm using a PC right now, so I'll go to Statistics, Distribution Plot. If you're using a Mac, you'll go to Statistics, Probability Distributions, Distribution Plot. Select Display Probability. We're constructing a t-distribution with 48 degrees of freedom. We're looking for the t-values that separate the middle 95% from the outer 5%, so we have specified probabilities. I'll select Equal Tails because we know that 5%, which is the default, is equally split between the left and right tails. Our t-multiplier is 2.01063. Next, we need the standard error of the slope. We can get this from the coefficients table. We're still looking at the row labeled as the x variable. Now we want the column labeled SE_coef. That stands for standard error of the coefficient. That value is 0.1414. First, we multiply, then subtract and add. Here's our 95% confidence interval. To interpret this, I would say, I am 95% confident that the slope for this model is between 0.4670 and 1.0356 in the population.